Okay, today we're talking about inverse variation, but first let's actually talk about direct variation. So this is a review of something you've had, which is this formula, y equals kx. Remember, k is a constant. It's actually not a variable per se. Once you find out what it is, you want to write it down. The graph looks like this. What that means is as x increases, y is increasing. So x is going up, y is going up in a proportional way. It's going up not maybe the same amount. You can see it's not same. Maybe x goes up by 1, maybe y goes up by 2 or something. That's the kind of idea here. So like on this one, you can set up proportions. Direct variation work really well with proportions. So like you can say, well, $60 is to 8 hours in the same way that 20 hours would go down here, right? Because hours are in the denominator. So you keep things kind of symmetric and solve, and you can solve that out. I think it gets 1200 there equals 8x divided by 8 divided by 8. Let's see, 150. So x equals 150, I think. The other way is to use kind of equation like y equals kx. Let's try that. So let's plug in our variables here. So we make $60. We don't know what k is. That would be our rate, like our pay rate, like $10 an hour or something. And you work 8 hours, so times 8. If you divide by 8, I think you get k equals 750. The advantage of getting an equation sometimes is now we have an equation, y equals 750 times x. Or even to put it in context, salary equals 750 times the amount of hours worked. That might make more sense. And now we have an equation that we can actually use in this context. Okay, inverse variation, write down the equation, write down this. You don't have to write down the example. This is an example of the big concept first, which is as x increases, y is decreasing. So x is maybe going up, y is definitely going the other direction for inverse variation. So like this formula is, pressure is Boyle's law. As volume increases, the pressure is decreasing. As volume decreases, the pressure increases. So that's just something you might have learned in science class. Speed varies inversely with time. What that means is as you go faster, the time actually goes down. As you go slower, the time gets more, like the time you take to get to school, for example. If you drive slow, it takes more time. If you drive fast, it takes less time. Okay, so this is mostly just plugging in. It says, use this equation. We've got these numbers here. So y equals k over x. What could we do with our x value and our y value here? We're going to plug them in. 14 equals k divided by 2. We're going to multiply by 2 because it said it's, I think it said it's inverse, varies inversely. So there's inverse variation. So times 2, we get k equals 28. Now that's not our equation. The first part of the question says, write the function that models the variation. So now that I know k is 28, I'm going to plug it into the function. So I'm going to plug that in right there. So I get y equals 28 divided by x. Now x and y can be many different things, but for this problem, the k value is always 28. The second part of the question says this, find y when x equals 5. Okay, so y equals 28 divided by 5 is the answer. You could also, it says you could graph this. So let's just try that and see what that looks like. So if you were to graph the function, again, the function is y equals 28 over x. So if you go to graph, and you type in 28 over x, it should have a look of, whoops, sorry, I don't think I typed in the right thing. Must not have caught. Okay, so it should be a fraction, 28 divided by x, not 28x. And there it is. You can probably see, it has this look of, in the first quadrant of, as that is inverse variation, that's what it's going to look like for sure here. So if you go trace menu 5.1, you can type in a value like 4, it jumps there, but 5 is the one we want to know about. 5, the answer should be y equals 5.6, which is the same answer. So if you use your calculator, you got 5.6. If you just plugged it in, you got 28 or 5. Those are the same thing there. Similar problem here, inverse variation. So let's start with that. So we get y equals k divided by x. We're going to plug in. So 3 equals k divided by 15. So solve for k, you get k equals 45. We're going to write an equation, y equals 45 divided by x. At that point, and then it says, what is, when x equals 5, what is y equal to? So at that point, you can either graph it in your calculator, 45 divided by x, trace it, menu 5, 1, type in 5, and since the y value is 9, you get it. Or you could just literally plug in 45 divided by 5 is 9, and you get it that way. Okay, these are a little tougher, so you want to get figure out, is it direct, is it inverse, or is it neither one? Because that's actually a possibility. So if you look at x looks to be increasing. It's going from 0.1 to 0.2 to 0.3 to 0.5. Y is decreasing, so I'm thinking maybe inverse, but I have to check it, right? So to check it, what you want to do is plug in. So you choose kind of a point. I'm going to choose that first point. I'm going to plug into the inverse equation. So k divided by x. Okay, so this will be 30 equals k divided by 0.1. If I multiply both sides by 0.1, I get 3 equals k, or k equals 3. Let's try it on the second point. So we get y equals k over x. Okay, I'm going to plug in, so it'd be 15 equals k divided by 0.2. Multiply both sides by 0.2. That is actually k equals 3. Looks like it's going to work. One thing you might want to consider doing is you can actually just solve this generic equation for k by multiplying by x on both sides. You get k equals xy. So that's always going to be true if it's inverse variation. So if you just multiply, 0.1 times 30 is 3. 0.2 times 15 is 3. 0.3 times 10 is 3. 0.5 times 6, half of 6 is 3. So it definitely is, yes, it is inverse. The equation, if we know k is 3, is going to be y equals 3 divided by x. So I'll probably ask for both things. I'll probably ask what's the formula and what's the equation. So look at this one over here on the left. X is increasing, y is increasing, so it might, I say might, it might be direct. Sorry. So it might be direct, so let's just test it. The equation is y equals kx. Plug in maybe that first point there, so you get 3 equals k times 1, so k equals 3. Wow, that's weird. Okay, let's try the second point and just see. That's going to be y equals k times x, so 5 equals k times 2. Solve for k, you get k equals 5 halves. Well, guess what? 5 halves and 3 aren't the same. This is neither one, so it is neither inverse or direct proportions here. And this one, it looks like x is increasing, y is increasing, so it might be direct. So y equals kx, let's just try. So we plug in maybe this first point, so we get 8 equals k times 2. So divide, you get k equals 4. Okay, let's plug in the second point, so we get 16 equals k times 4. Divide by 4, you get k equals 4. I'm hopeful this will work. Kind of like we did with direct variation, let's just kind of get a rule. Y equals k times x. If you divide by x, you get k is always equal to y divided by x. So if that's always the same, if you do 8 divided by 2 is 4, 16 divided by 4 is 4, 24 divided by 6 is 4, 40 divided by 10 is 4. So yes, it is in fact a direct variation. And the k value is 4, so the equation is y equals 4x. And this one is very similar to the problems we've been doing. It's just written a different way. It says it's direct, which means the equation is y equals kx. It gives us x and y here. What should we do with those? Maybe plug them in. 12 equals k times 3. So we divide by 3, you get k equals 4. My equation would be y equals 4x. Plug in this value here for x, so y equals 4 times 11, which is 44. I'll take 11 right there. So we get that the second answer is, find y. We found it is 44. Okay, find the missing value. If it's inverse, so we would start with the equation y equals k divided by x and y, plug in, so we get 5 equals k divided by 3, multiply both sides, so k equals 15. So my equation is y equals 15 divided by x. That's my function rule. Plug in 1/2 there, so we get y equals, ooh, this is a little tough, 15 divided by 1/2. That's like multiplying, that's the same thing as multiplying by the reciprocal, which is 2 over 1, so we get 30. 15 divided by 1/2 is actually a bigger number, it's actually 30. So we have the function rule and we have the value of y when x is 1/2 on that one. And that is your lesson. Sorry I was going fast, I was trying to get it in before ALAP was over here. Thanks.